Good morning, everyone. I hope everyone is doing okay and ready for another exciting day. If you could hear me okay, let me know in the chat and we will quickly get started. Yes, thank you. Thank you for confirming Amrendra Ranga Grand Blue. That's a nice name. Pawan is here, Yuri is here, Haripriya, Babita. I think there was some confusion about the daylight timing changes. So probably it happened in US, I guess so. And we are scheduled for a daylight change next week. So we will talk about that also, like it will be changing something on that. So that's completely fine. These things always gets you a surprise, isn't it? So I'll quickly add who else is joining me today. So we have James after a long time. So let's say hello to him. He's jet lagged,
No,
so don't worry about his looks. He's looking as good as always, but yeah, he is jet lagged a little bit. Hey, Michelle. So we have Michelle also with us, and we are trying to answer as many questions as we have. And now we have James back. We would be hearing more from him also in the technical track. So not only me, I would be not bothering you every time, but yeah, there would be more people who would be helping us. So let's keep moving forward and we will discuss about interesting stuff. And keep your questions coming. You are in safe hands. We would try to answer as many questions as we can. And even afterwards, once you watch your video or you are watching recording and you have some question, feel free to put them into YouTube comment. We monitor it and we would be happy
feel
to
free to
answer
put
those
them into
questions.
YouTube comment. We monitor it and we would be happy
Feel
to
free to
answer
put
those
them
questions.
into YouTube
I
comment. We
don't know what
monitor
happened
it
here.
and we would be happy
Feel
to
free to
answer
put
those
them into
questions.
YouTube
I
comment.
don't
We
know what
monitor
happened
it
here.
and we would be happy
Feel
to
free
answer.
to
Feel
put
free
them
to put
into
them into
YouTube
YouTube
comment.
comment.
Okay, there was some echo coming up. I hope everything is okay now. James, Michelle, is it okay? Can you give me thumbs up? Okay, good. Thank you. So let's move forward and we will then move forward and discuss about the interesting stuff. Let me add the presentation and I'll hide myself from the screen so that you can focus more on the content part of what we are going to discuss for today. All right, so pretty busy, interesting way of doing things. We would start with the networking track first. So we'll discuss about what is into the networking. We will talk about what is the name Route 53 and DNS resolver. We will then talk about technical track, which is DynamoDB, and we would have then hands-on on Amazon DynamoDB. So this is the agenda, and the agenda for next week is already there on to the BESA page, but in case you want to add something, like we are getting a lot of inputs and we are actively looking for incorporating those inputs as we move forward to this training. So we are still into planning phase for behavioral track. We are thinking to make little bit of behavioral and little bit of technical also mixed up, probably at least answering the question. So that is the plan for the next hour or so. Yeah, loop happened, but now if I hope everything is okay. So let me quickly get started with this particular training or this module, which is about networking. Let me quickly get started with this one. I hope everyone can see the screen. And what I want to start with is a famous quote that will be related to Route 53 and DNS resolver. So we will talk about what is Route 53 and what is DNS resolver, and we will keep on moving forward on that. Now, I have an announcement also to make before I move forward with that. We have Parna, and Parna has joined us as a BESA volunteer. She is in Amazon now, if hopefully everyone remembers, and then she will be also helping us with the planning part of it. So, welcome, Parna, and thanks for your support on it. You were already doing it without even being called for, but yeah, that is good to see you into the team of BESA volunteers and helping others also. Now, what I'm showing on the picture here, obviously, people would be reading this right now. So, this is a famous quote from Albert Einstein, who is from Romeo and Juliet, which says, "What is a name that which we call a rose by any other name would smell as sweet?" Right? So, there is nothing in name. The rose would still be rose if you call it by cauliflower. It would still be there, same smelling. It would be still that beautiful. It would be still symbol of lots of things for multiple people. So I hope that is everyone is relating to. Now, do you see anyone problem with this statement from Albert Einstein? Anyone? Is anyone? I'm trying to like put a dad joke here. If everyone gets it, good. Otherwise, that would be a bad attempt from my side. Anyone seeing anything wrong with this quote from Albert Einstein? Identity crisis, readability. He is a scientist. All right. Yeah, good. Right. Now, the challenge is here that I have intentionally put a trick on you. This was not called by Albert Einstein, and I know that a lot of people are saying that, hey, Ashish, you are dumb. Albert Einstein was a inventor, a scientist, not at all a author of Romeo and Juliet. But the point I'm trying to clarify here is what is the name, right? Though we have the meaning conveyed to us that what we are trying to say, but we always relate things to the people who have said it or which we are trying to relate as of now. So that is the exact same thing we want to discuss here. So yeah, it was Shakespeare. It was William Shakespeare who has wrote famous Romeo and Juliet, and these are some of the lines Juliet says when she is confronted. But yeah, this is something which has lots of implication. I've been into arts. I've been an art student. I completed my master's in arts in English literature after completing my graduation and master's in computer. So I'm little attached, and I thought let me take this opportunity to talk about what is in the name. So name has a lot of significance, right? We always refer people by name. If I call you by a different name, you would not be happy, right? You want people to address by the name they have, and that's what we are going to discuss into this module, that what we can do to make your name stick and how we can easily resolve the thing. So the topic we are discussing here is DNS. I'm hoping most of you know about DNS. So DNS, or the domain name system, translates human readable domain name, for example amazon.com, to machine readable IP addresses, for example 192.0.2.44. So why we need this? Now again, I prefer to use analogies to explain things, so let's go ahead and see that information. I'm not sure how many of you remember these telephone directories, or what we used to call phone books. They are extinct now, like dinosaur. But yeah, at a time, it was the only way to look for someone's name. You would go through a lengthy and book or very heavy, thick book, and in that you will find lots of name, and there would be always a confusion and looking for very small print. But yeah, this is how we used to get a person's number, because we cannot remember number of everything. So yes, it is yellow pages. It is referred as sometime as a telephone directory or phone book. So yes, you can find someone's name if they are listed here, and then you should be able to call that particular person. And probably people, some of you still remember the old phone which I am displaying here. I remember picking up that phone and talking to people. Nowadays everything has changed. So point I'm trying to clarify here is that yeah, every year a new version used to be released, and there would be always some mistakes in printing, which would create a lot of issues with people. So yeah, that always happens, isn't it? So that has changed. Now, humans, we do not want to call by number. So calling someone by dialing their number would be very, very difficult for us. We can't remember those many numbers, but what we prefer calling people by their name. So in our phone, we would have a name, and we would click on that, and that would translate the name to the number, and then we would be able to get to that person. So that is a simple thing which we follow for our phone books. DNS is nothing beyond a phone book, but it is a distributed phone book. I'll talk more on that. So humans, they require name to communicate, and that makes them comfortable and they can remember things properly. Numbers not that great, so that's why we have a gap here between humans and machine, and DNS is trying to bridge that gap. Let's go ahead and now talk about how DNS actually works. I hope everyone is following along, very basic stuff. And now we will see a little bit of DNS and then see how Route 53 helps you in this case. So let's say I opened up a web domain, let's say www.example.com, and now I want people to come to it. Let's see what are my methods for it. So this name which I have to go to a DNS provider, and that DNS provider would allow me to register my domain. In my case right now, I am thinking to use Route 53, but Route 53 is not mandatory. It will be something which can be like someone, you can use another service provider or any other company, that is completely fine. But we will confine here to discussion on Route 53. So what you could do through Route 53, you could buy domains. Like if I am having a idea and I want to build a domain or website, I could buy domain from Route 53, or I could register my existing domain to Route 53. Maybe I bought it from some third parties like GoDaddy or maybe ukname.com, but now I could go ahead and get this domain registered to my Route 53. So when I register a domain, what I have to tell what is the domain name of me and what is the IP address I am responding to, right? And obviously I can't just randomly register name. They would ask me to perform some security check by adding some DNS record or verifying the email ownership, and then only I would be able to add and register a domain name. So let's say I have done that part, my domain is registered, and now I have a user who wants to talk to example.com. Now, example.com is a name. Machines do not know that. So, what they have to do, they have to do a DNS resolution. And that's why probably the first hop they would take will be to go to the DNS resolver of local ISP. Whoever is your service provider, they would have set up a DNS server or maybe a forwarder at least who would carry your request to next thing. So, that should be of the way of doing things. So we would be having a local ISP which will have a DNS resolver or a DNS server, and that would start helping us in reaching out to example.com. So all over world there are 14 root servers. When I say 14 root server, this doesn't mean only 14 boxes, but there could be group of cluster. There are called dot domains, and these dot domains are actually allowing me to perform on the name resolution. Now, when I talk to say I want to talk to www.amazon.com, actually behind the scene, it is considered like this. So Amazon.com and then one more dot, and that one dot we am saying here is representing these 14 root domains of cloud of internet. So all these internet traffic for DNS relies on these 14 domain name server. They are spread across geography, maintained by different independent authorities, so that no one single person is controlling that thing. But that would always happen. So first request, if my DNS doesn't know, like I'm trying to talk to a person, if I do not know their number, I have to consult. So maybe I would go ahead and look for that into root domain server. When I say I would look for, probably it will be done by the DNS of my local ISP. So it will go ahead and say to this root server and say, hey, do you know anyone with the name www.example.com? This server will say, I don't know that person, but I know someone who is responsible for .com. So what they have done, they have put hierarchy, and then everyone has, let's say, .com domain, .uk domain, .in domain. These are different domains which have been subdivided for efficient work or a hierarchical design. So that DNS server will respond that, hey, I don't know about example.com, but maybe check with .com, so that there would be a good way that he or she may know about that particular server, right? Let's say you want to talk to someone in Amazon. Now you just know the name. If you talk to the help desk and say I want to talk to this person, probably it won't happen. So you may have to figure out which country, city they are working in, which office, and then maybe you can start making some local calls there. Similarly, same thing here. What you would be doing now, your ISP probably will go to look for example.com on the .com servers. .com server will say, okay, I am authoritative for that, but I still do not exactly know who is example.com, but I know the server who has registered their domain name with me. So it will probably respond with the Route 53 DNS server name, and Route 53 is where my domain is registered. So my ISP would make another call to example.com, so domain server, which is DNS route 53, and this would be responding me with the IP address. So now I have a domain name resolved that example.com is existing on 12.4.3.7. This information will be cached by DNS resolver of local ISP, so that the next request when it comes, it can be delivered directly, and it would also forward that detail to the user who requested, and user would probably also be performing a caching of DNS, so the next time he doesn't have to make that call. DNS cache is like your phone's last dialed numbers. So if you have made a call to someone, that would be in your last dialed number, and that is a cache which you are maintaining. And once you have that cache, you do not have to go back and back do back and forth to the DNS servers at all. So that's why caching helps. So DNS caching is maintained that decide on the client side how long the cache has to be created and how long it has to be kept. Sometimes these servers also set up a TTL value, which stand for time to live. So once they send you the DNS information, they may say that, hey, this is valid for 30 minutes or so. After 30 minutes, come back and get a renewal. So this is what the process is. And once my user got that IP, their browser will make a request to 12.4.3.7 and the request will be forwarded with the details of it. So that is how DNS actually works. Any questions, anyone so far? Any doubts, any confusions on this? Pretty basic. I'm sure most of you know about it, but it is always good to have a base platform ready and then move forward on that. Okay. Now, what is DNS basically? DNS behind the scene is a database of record, not the traditional databases, but it contains some information about different type of records, and these are called DNS records. So in a DNS, consider like there is a huge book, telephone book, and it has a name of person, let's say www.example.com and a IP address. If there is a mail server, then it will be called a MX record, which is representing a mail server of it. If you have, let's say, a DNS server, so that will be called a NS record, for it is called your name server record. If you have IPv4 addresses, they are considered as a quad A record. So these are different type of records which you could create into your DNS server depending on permissions you have. So Route 53 is a service which allows you to create domain names by domain name as well as to have existing domain registered to Route 53, and in that it allows you to provide lots of ways to create different type of record. I have listed some of them, but there may be more type of record which you may have, like name server, authoritative domain, and then other type of things. So hopefully this thing is clear. These are different type of record. Examples should be clear. So a record is we call address record is representing a domain name with the IP address. When I say it is a quad A or 4A record, that is representing a IPv6 address. Then CNAME is called canonical name, like you may call somebody by this example.com www, or you may also refer them as web.example.com. So that is a canonical name, point to one domain or subdomain of another domain name. And then there are alias records, which will be very useful for AWS resources, because let's say when you launch a load balancer, this is how the name would look like: ELB01 dash something EU West 1. Nobody can remember it. So you would create an alias record for, let's say, example.com, who would make your life easier, and it is basically a alias to this particular person. Are we good? So this is what are the types of record which I may see, but these are just some. I think around 15 type of different records can be created on DNS server depending on which server you are using. All right. Now a random question here. Does anyone know why this service is called Route 53? What is the significance of number? Anyone? Why this service is called Route 53? Why not something else? Yes, it is the port number of DNS. So DNS is using port number 53, and that's why it is called Route 53. Somebody thought a creative name for that. That is good. Now, another question. This may be a little tricky. Is this 53 used for the protocol TCP, or is it UDP, or is it both? What protocol behind the scene we use for DNS? Not we means all the DNS servers. Anyone? What are the behind the scene information which you utilize on this? Anyone? Both? Yes, that is true. For some situations, we would be needing both type of protocols. Can anyone give me more detail? Any specific time when a UDP is used and when a TCP is used? So there is, whenever you have a DNS name resolution request, that time it uses UDP protocol. But when there is a DNS zone transfers, which means one server sharing their information with another servers. That time it uses TCP because it's a data we are copying, and that's why will require that type of services. So both type of data can be accessed by, there is a UDP protocol also, and there is a TCP also working behind the scene. Name resolution work on UDP, whereas zone transfer between the DNS servers work on TCP. So this is just a trivia information. I hope you are clear with that. So what I'm trying to do now, I want to log into AWS console and see Route 53 into action. So Route 53 is a global service. I would just go to that and I would be able to see the details of it. And what we do, we maintain this Route 53 service across multiple servers from the globe. So all the places we have multiple servers on .co.uk and on all other places there were servers run. So I'm on dashboard here. What I could do from here, I could register my domains, right? So if I'm looking to buy a domain, I could go ahead and transfer. I could register a new domain for that. I could check what is availability of that .com, .net, .org, and I could go ahead and check and then buy that domain. Shouldn't be a problem. Or if I already have domain purchased, I could transfer that domain to this particular Route 53 service so that we can look for, should not be a problem. And apart from that, we also allow you to create something called hosted zones, which will be carrying multiple records of your domain. And these can be internal, private, or these can be public also, should not be a problem. So idea of this hosted zone is, it is the place where all my records would be maintained. So let's say if I want that, I want to create a hosted zone, which will be called AWS dot internal. This is what I would be using within AWS, or example dot AWS, that is up to me. And I could go ahead and say, is it a public hosted zone or is it a private hosted zone? Public hosted zone determine how traffic is routed on the internet. So they would be a internet friendly kind of a stuff, means any resources which you want to have a public domain name, you would require this. I am interested right now in creating a private hosted zone, so I could go ahead and create a private hosted zone. These zones, when I create, has to be associated with a VPC. Unless I have a zone associated, it won't be working. So what I could do, I could select a specific region and I could associate my DNS name to those VPC in those locations. So let's say I have a VPC called VPC-A in Northern Virginia, and I could have created this domain name hosted zone associated with that. So a concept of hosted zone is that all the name resolution for this VPC will be maintained by this hosted zone. If you want to add a record, you would be adding those records in this particular place. Okay. Now I have a question for you. So what you see right now, that we created something called a hosted zone, and I have associated with a VPC. Right? So this VPC would always be referencing, let's say this was example dot AWS. So if I have a machine here, which is called machine A, its name will become A dot example dot AWS. If I have a machine called B here, it will become B dot example dot AWS. My question is, if I have another VPC, so this was my VPC 1 and this is my VPC 2, can this hosted zone be also associated with a second VPC? Anyone knows about it? Can I associate same hosted zone with multiple VPCs? All right, Pawan is going for yes. Answer is yes on that. That is completely true, because now you may have resources here called C and D, and they all can now be referred as c.example.aws and then a.example.aws. So that was easy one. Forward zone is little different. We will talk about forward zone. Now I have to, like, throwing curveballs to you, asking another question. Can I have another hosted zone, and this time I am calling it example 2.aws, and can I also associate with this VPC? What do you think? Can I have a different domain name, or sorry, is hosted zone also associated with the same VPC? Now I have two. My questions are always tricky, isn't it? Answer is yes in this case. You can. So sometime when we have a requirement like I want to be known like I'm migrating and I want to keep the same domain name as we were doing in on-prem and then relate it here also. So yes, this is possible. It confuses people, but yes, technically it is possible that we could have this kind of architecture too. Shouldn't be a problem at all. So I hope this association is clear. I'm keeping it simple right now. I have just associated with one VPC and I have created the hosted zone. That's all I have done. So once this hosted zone is created, now I could start creating records in that what I was referencing to. And if you see this example.aws, this is having NS. NS stand for name server. Yeah, it was confusing. I agree on that, Pawan. But yeah, it is there. You can do that. So that is mostly helpful when you are migrating from on-prem and you do not want to migrate you don't want to change the domain name of on-prem, but want additional name for your AWS resource. So that time you could use it. Now, what happened here? Just as soon as I say I want to host a domain called example.aws, it was internal. There is a name service created, name server. What AWS did, AWS picked up 4 physical servers from all over the world and kept your details there. And if you look at it, they are all are like ns1536.co.uk, .com, .org, .net. Idea of keeping this information in a separate servers is about ensuring reliability of the service. So let's say there was an outage somewhere and all co.uk domain servers are down, still your name resolution will work from these com servers or from org servers or from .net server. So this will always be splitting your information across multiple servers. And if you physically look at these servers, they would be spread across multiple geographies all over the globe. So even if a section of a globe is having a DNS issue, probably it won't be having a problem with that. Right? Do we a name for the service where we could have a VPC associated with 2 different hosted zones? Same route VPC, right? So this is my hosted zone. I have internal.com example.aws. I have associated that. I could go ahead and say, okay, what you are this, and let me add another VPC to you, and which is in Northern Virginia, and I am still associating the same VPCA on that. So this is not a service, Priya. It is still the same interface. And now if you see on that domain name internal.com, I have associated with Frankfurt and US East. And if you remember, US East I have already associated with example.aws. So that's how we would be identifying these information. Will latency is affected when one or four name server goes down? Ranga, I don't know. Probably not, because this is like not one server, but this is again a cluster of servers. So we call it as NS1536. It doesn't mean that there is one physical server. This will be a group of clusters. So probably it won't be affected. And then if you feel like that, you could go ahead and then create latency based routing records if the need be, but I don't think it would affect anything. And this service is Route 53 is someone which has highest SLA for any AWS services. So Route 53 SLA that is there, that this has a high SLA to be kept. So because we are splitting it across multiple physical locations, so we should be able to provide a higher SLA for your services. So serious monthly uptime service credit, we explain less than 99.95%. That is what we can be having. So this is a high service in terms of reliability of it. Okay, so I could create name record. So let's say I hosted a web server now in my domain, so I will call it www. I am creating a record here, which is an address record. And if let's say my server is running on 192.0.5.5, I would be 4.4, let's say I would put it, and this is the TTL I was explaining, that how long this will be kept active in someone's cache. And here are different routing policies which I could have selected, like weighted, geolocation, latency, failover, and multi-value answer. These are all the options for me to use. And now I go ahead and say, okay, let me create my record. So now if somebody comes and asks for www.example.aws, we would tell them that this is the IP address. Now we have not performed any health check on it. We are just translating. So like you go to phone directory, it will tell you what the number is, but it won't tell you whether that number is operational or is somebody going to pick up on that place or not. And for those type of things, what you could do, you could create something called health check. So health checks can be created if you need, but we will talk more on that as the time goes, right? So I hope this is clear. And now I will focus little bit on the different policies. I've shown you one policy, but you could have selected different policies. So let's say I have two web server who could respond, three web server who could respond to my example.aws. I could have added those policies with them. So with these, I have option to edit a record, and I could have selected different routing policies on that, like weighted, geolocation, latency, failover, and multi-value answer. So I'll talk a little bit on these policies. Keep your questions coming. If something is not clear, I would be happy to answer. Simple routing policy is simple, as the name says, that I would have a record behind the scene and we will just forward request to that. No further complications. One-to-one kind of a mapping. You ask me who is Ashish, I would give you his number. Done. Weighted is different. In weighted, what we are seeing, let's say I have a bigger instance who could 100,000 requests, and I have a smaller instance who could handle only 100 requests. So what I would do in this case, I would say I want to give more weightage. So if I have 100 queries coming in to resolve the name of the domain, I would say 90 you would be giving these addresses, and 10 you would be giving this address. So this is dot one, let's say, and this is dot two. So for 90 requests out of 100, we would say more weightage should be given to this. So when you have multiple resources that do the same job and you want to specify the proportion of traffic being forwarded to them, then we will be using a weighted round robin, sorry, weighted policy. Weighted ensures that you are maybe releasing a small amount of traffic. Let's say this is my new version of application. I would just send 10% traffic, see if it is working fine. Then I will come back and change it from 90 to 50-50. And once I'm happy with newer application, I would say 0 and 100. So weighted is useful in those cases. Okay. Next policy is geolocation. Use when you want to route traffic based on location of your user. So let's say if I open amazon.com, what it would do, it would redirect me to amazon.co.uk because that is nearest to me. Similarly, if somebody opening it in Australia or India or China, it would be having a different way of doing things. So it detects what is your location based on the IP addresses. IP addresses are allocated based on a specific latitude, specific area, like a country or a service provider. So it would check that the information and based on that route you to the nearby location who is near to you. Like when you want to withdraw money from ATM, you don't go travel 10 mile, 15 mile for a specific ATM. Whoever is nearby, you go to that and withdraw money. That is what a geolocation is giving you. All right. Latency is similar but different. Let me explain. Latency is also making a decision, but the decision is now based on latency of it. So let's say I am in UK and I have a server who is in London and another server who is in France. But due to some issue into London networks, my latency to reach is 10 millisecond, and here I am getting answer in 5 millisecond. So physically I am in close proximity to London, but it will be always forwarding my request based on the latency. So it will check, okay, what is the latency for A? Latency is 15 minute, latency for B 6 seconds. Let me go ahead and send information there. So that would always happen if the need be. I always been confused with question asking to choose between a load balancer and Route 53 though. Use case for load balancer pretty well. Uh, so we will talk about that. We will discuss that. So see, load balancer is a traffic receiver. DNS Route 53 is just the name resolver. So load balancer, think like, let me give you an example. Let's say you make a call to Barclays Bank, right? I'll give an example. My credit card has some fraudulent transactions and I had to call Barclays Bank. So I didn't know their number. So what I did, I went to Google and searched for Barclay credit card fraud helpline number. So it has delivered me a number, let's say 1800 123 456 78. Just give me an example. This is my DNS. It has told me where I can reach to Barclays team. Now, is this only one single person sitting on this phone number? Probably not. So this is a board number. Your request will come to it, and then there would be multiple agents behind the scene who would be picking up the call when I am making the call. And this is what my load balancer is doing here. So Route 53 just resolves the name. It may give you A or B or C or D. When you make the call, then your request is forwarded to agent behind the scene who would be having bandwidth available, or maybe a special department. So where to forward will be decided, or who would respond to you, that will be done by load balancer. Where to forward, or where, what is the address, that is best thing is what is the address is given by your Route 53. I hope that makes little sense to you, that how this will be different from Route 50. So Route 53 just forward just results in an IP address given to you, and then load balancer will automatically forward the information to you. All right. Nice, good, thank you. And thanks everyone for pitching in and sharing information. So that is my geolocation. This is what you say use when you want to route traffic based on location of your user. Latency is again same thing we discussed. Failover. Failover is, hey, primary is this, and if this is sorry, let's say this is primary, and if this fails, then stand request to standby. So we check health of it, and health failed, then we say, okay, you are not there, let me go to the next person who can answer my call. So that is called my failover, right? Failover, think like you have out of office messages, right? So when somebody receives, let's say I ask Pawan to be contacted and Pawan is not there, I got out of office message. Then it may have information that if I'm not there, talk to maybe Ashish and he would help you with your query. So that is my failover. He was not there. So that's why my request went to Ashish. So that is my failover option, right? Then comes multi-value. This confuses people. Multi-value is a poor man's load balancer. Let me explain what it is. It says use when you want Route 53 to respond to DNS query with up to 8 healthy record sets selected at random. Let me try to draw that. This is something confuses a lot of people. So let me explain multi-value answer. So I am explaining you about multi-value. Right. So let's say I have a server www.example.com and I have multiple IP address. I have 1.1, 2.2, 3.3, 3. Or 4.4. These are different IP addresses which are there, right? So on, can be multiple, right? So I'll not type, but yeah, that you can think there are multiple. Now, if a request comes in, if a user is here and he says, hey, I need example.com IP address, what would happen in this case? That we have multiple values available. One option is I give to this user, okay, answer for that question is 1.1, go and talk to 1.1. This user goes and talk to 1.1, 1.1 doesn't respond, it comes back, hey, you gave me a number, it is not functioning, do you have another number? This one says, yes, I have, try 2.2. 2.2 not functioning, okay, let me give you another number, 3.3, and then you try to that. So what is happening? My client is making multiple trip in case one of my record is not working. That may not be very efficient. We want a efficient design. So what you could do in case multi-value answer, you could say, okay, client, what you want? You want to talk to example.com. I will give you, let's say, 8 addresses of that 1.1, 2.2, 3.3, 4.4, and so on. And you keep all of them and feel free to talk to any of them, right? That is a multi-value answer. So multi-value is a poor man's load balancer, because what may happen that this is another user, user 1, user 2, user 3. It may happen that all of them got 1.1 to 8.8 IP addresses. This one made a call to 2.2, this one made a call to 3.3, this one made a call to 1.1. So that's what is a multi-value answer, where multiple users, multiple records are returned by Route 53, so that you would be able to talk to any of them, and the decision to who to talk is referred on the client. Like you say, Ashish, share your contact details. So I send you my WhatsApp, I send you my mobile number, I send you my email address, I send my LinkedIn profile. You decide where you want to contact. So that is a multi-value answer which we are trying to understand here. I hope everyone is following along and getting the idea of what. So this is all the different policies which you have. And one which is not mentioned here is geo proximity. I think it was already answered into the chat, but geo proximity is basically based on latitude and longitude of your request. So now I am into US. Now physically I can reach to US East 1, US West 1. So US East here and US West here, right? So US West, where I should go. So it will check who is closer in terms of latitude and longitude and forward your request on that. So that's how the things will work. So it ensure you don't get 404 with multi-value. Answer is no. Coffee Brown, that may not be true. What if all 8 records are unhealthy? Right? So it may happen because we checked health and forwarded it, but by the time your request reached, maybe it became unhealthy. So it's not a guarantee that you will not have 404 with this. 404 is is a issue on the request, so it may still happen. It is not a guarantee that because of it you will not have a 404 at all. So these are different routing policy, and I will keep this information into chat into the resources section. It is already there, so go ahead and check for it. Any more questions, any doubts, any confusions, anything which is not clear on that? Now we are running a little behind the time, so I'll quickly go through the next topic, which is Route 53 Resolver. I wanted to talk more on that, but yeah, that is little time constraint. So I'll keep slide. I'll quickly talk about it. But in case you have any question, feel free to get in touch. I would be happy to answer questions of Route 53 Resolver inbound and outbound. Let's see how this particular service works. This is important for your exam perspective as well as your design perspective, because this is what you would mostly be doing when you have a hybrid DNS architecture. Let me explain that. So let's first talk about what happens within a VPC for DNS resolution. So I'm just creating a VPC here with 10 series. It has a subnet displayed, but obviously it may have multiple of them. But what I want to explain here, that in every VPC, a IP address is reserved which is used for all the DNS query to be forwarded to. That is called my Route 53 resolver, or sometimes people just call it as a .2 resolver. So .2 resolver is the IP address which responds to all my query. Think like your DNS server is running here. So as soon as I have created that hosted zone example.aws, it has automatically created an entry in .2. So all my requests of that VPC would be resolved by this. So if A wants to talk to B, it says, hey, what is the address of b.example.aws? It knows about it. It will tell this is the IP address, and then A and B will communicate. So this happens within a VPC. .2 resolver helps them in getting all the queries sorted. All right, hopefully this thing is clear. This is what happens within a VPC. DNS query is always forwarded here, and you get response coming from that. What next? Next is that what happens if I have a on-prem infrastructure. In on-prem, you would have a corporate data center. Let's say it is in a different IP address range. You would host a on-prem DNS server, maybe use a Microsoft DNS service or use Linux Bind or any other third-party DNS software, but you would have a server who would be your on-prem DNS server, and your machines will be configured to ask this question to this server locally. In their IP address, DNS setting would be there, so they would automatically go and ask all the questions here. Right. So every machine when I'm booting probably would have a IP address, so that I should be able to get all my requests associated with that. So let's say if I go ahead here on my local laptop, I'm using ipconfig/all, I would be having some information about DSCP, and see this is the DNS server I am making call from my machine to go outside to any world. So every machine would probably have a DNS server entry, and in this case of on-prem, that entry would be of your DNS server of on-prem. So that works fine. Now this OP1 can talk to this machine and say, give me address of OP2. It will give, and OP1 and OP2 will communicate. But the challenge here is that they do not have a visibility of cloud, and cloud doesn't have visibility of on-prem, and that's we want to solve. So maybe we have taken care of physical connectivity. So this is my physical connectivity which we have sorted, and through this physical connectivity I can send packet from 10 to 172 and 172 to 16 to 10. That is not a problem at all. So this is has been taken care, physical part. Now let's see what happens when B says, hey, I want to talk to op1.example.onprem. Here the domain I have selected is example.onprem. In DNS of AWS, my domain is example.aws. They are not aware about each other. So what need to be done? My client would always make requests to the dot to resolver, no exception, unless I modify that. They will always make requests to dot to resolver, but dot to resolver doesn't know what is example.onprem. So what we could do in this case, we could create something called a resolver rule. And in this resolver rule, I will say, okay, if you want to talk to example.onprem, forward it to a DNS server which is on-prem. Okay, so on-prem DNS server, let's say has address of 172.18.1.1. So I want to forward, but I would need a network interface to initiate the communication. So what happens when you create a outbound resolver, we create a network interface for you in the choice of the subnet, and that is basically a network card which would have IP address, and that would be having a security group also. And now my request through that network card will be forwarded to on-prem server. And now I will ask question, hey, who is OP1? And it will respond that OP1 is 172.18.5.5. I will pass this information to B, and B will then make communication to OP1 or OP2. So that's how your outbound resolver works. It always require a network interface, and through that network interface, we would forward request to on-prem DNS server, and we would be able to utilize all these things on that. When you get time, please create a Udemy video on Route 53. I plan to, Pawan. Only thing is time. Yeah, but I am having some plan time coming up. So yeah, I'll put a video on Route 53 on Udemy. I'll try my best. So this is what we solved is a AWS machine trying to on-prem. We solve that problem. We are able to resolve op1.example.onprem by leveraging something called a outbound ENI through a resolver rule. Okay. Now, question comes, this is one way. What if my OP2 here says, I want to talk to a.example.aws? That is again a challenge, right? Because here what is happening that OP2 knows about example.onprem, and it will send its request to on-prem DNS server. On-prem DNS server again doesn't know how to talk to OP B here or to the domain example.aws. So what you could do, this resolver is a common approach which exists in on-prem DNS server also. I can also create here a resolver rule which will say, if you want to get domain resolved for example.aws, forward it to. Now, two is what? Two should be IP address, two should be a network interface. So what I have to do, I have to create here a Route 53 resolver inbound network interface. So there are two type of resolver, outbound resolver and inbound resolver. Inbound resolver would have an IP address, and that IP address I would be putting into resolver rule of on-prem. So my request will be forwarded to it. It will talk to the dot to resolver, get the IP address of b.example.aws or a.example.aws, and deliver this information to this machine here, and they would start communicating. So this is what is called Route 53 resolver. They are useful when you have a hybrid architecture from on-prem to cloud or cloud to on-prem, so you could utilize it. 2 more minutes so that I could explain you into the UI. So this is my Route 53 resolvers here. If I go back here, see this, I can create an inbound endpoint. I could create an outbound endpoint. Inbound when I want to receive requests from on-prem, outbound when I want to make requests to on-prem. So I would create an endpoint. I would call it call on-prem or receive traffic from on-prem. I would obviously associate with a VPC. Let's say this is the one. If it is a network interface, I would need a security group. I would select what type of endpoint it is, and I would be needing a subnet where my LAN card would be created. And we always have requirement to have like this too, so that at least two network cards are created, and you can now create an inbound endpoint. So it is basically a network interface on which your request would be coming in. That was my inbound endpoint. Similarly, you could create an outbound endpoint. See this one. In this case, I would say, what is my domain? This is my example.onprem I want to talk to. This is endpoint name, endpoint. which VPC would be associated. Let's say VPC A, right? So cannot special characters. So let me call it on-prem only, done. And I would then say security group, which is required because it's a network interface, IPv4. Similarly, I would select which availability zone it will be part of, which subnet it would connect into. I could have one same subnet if required, shouldn't be a problem. And then I will say create outbound endpoint. So I have now created both type of communication so that on-prem and cloud both can have name resolution done. Network traffic can now flow by name, not just IP addresses. So this is hopefully is clear with everyone. Instead of AWS and it's shown, no. So see that time on-prem you create resolver rules. So see this ENIs is created Ranga in AWS. These ENI I'm maintaining in AWS. You would have here a IP address. So see this for outbound, I just need to talk to IP address. So I would have a path. My request will follow this physical connectivity and reach to this server. On-prem, I have created a rule. So on-prem when wants to talk to example.aws, it would also follow the same path and reach out to this server for getting the traffic. So instead, you can't create these ENI. These are network interfaces on AWS side. Here, you would probably have a router who would communicate and have traffic sent. So hopefully this is there. Both ENI has to be on public subnet. Answer is no. Why I would use it? See, do I see internet gateway here? Answer is no, I do not see internet gateway at all. I am using just VPN or direct connect connection on that, and it doesn't require me to have at all a IGW connected. So it could be any subnet. See, these are endpoint resolving your request. They have nothing to do with public connectivity. So I have kept it like this. So it will always have a internal IP. It will never have a public IP, right? So they would not be having a public subnet requirement. All right. Any questions, any doubts, any confusions, anyone? Okay, so I have taken a little bit more time than expected, which always happens. Let's go ahead and now take a short break for 5 minutes. And once we return, we will then discuss about more interesting stuff. So 5 minutes and we start again. Enjoy your time, everyone.